Last time we talked about the simplest formula, that lowest ratio of atoms, and we said that we needed more information in order to get to the actual molecular formula. Well, that's what we're after today. But just to kind of recap, particularly how simplest formulas and molecular formulas are related, I have a simplest formula here, and we're going to look at different possibilities for the molecular formula. If I think about the simplest formula as a building block, I can have one of those, 2, 3, 4, 5, 6, and so on. So if I had two of those building blocks, two of those simplest formulas, my actual molecular formula would be 2 carbons and 4 hydrogens. If I had 3 of those blocks, I would have 3 carbons, 6 hydrogens. If I had 6 of those blocks, my chemical formula would be C6H12, and finally if I had 10 of them, it would be C10H20. Now what's important to realize is that all of these possible molecular formulas have the same simplest formula. It's also important to understand this idea that the simplest formula can be thought of as a building block, not because it actually is, but because if I think about those blocks and having lots of them, that's going to be the thing that I end up using. So if I have a block and I've got a bunch of identical blocks, they're all going to have the same mass, and their total mass is going to be related to how many blocks there are. But let's start with that idea, not talking about chemistry. Let's talk about actual blocks. So if I had a bag of blocks, whether they're wooden blocks or cement blocks or anything else, that bag had a total mass of 98 grams, and each block had a mass of 2.8 grams. They're probably not concrete blocks at this point. Wooden blocks is more sensible. If I had 2.8 grams in every block, and a bunch of those blocks added up to 98 grams, how many blocks do I have? And that's a fairly simple, straightforward question, and I think you would know how to do it without even needing the instructions. You'd take all of the blocks together, 98 grams, and you'd divide it by the mass of each block, 2.8. And when you did that, you would end up with 35 blocks. And what's important to understand is not these kinds of blocks, but if I think about a simplest formula as a building block that I keep piling on to make a molecular formula, I'm going to do the same thing. Now if I take this idea and go a little bit different, if I had a Lego building and all of the blocks were exactly the same, made up of identical blocks because you got the not very great kit, each piece had a mass of 3.25 grams and the total mass of the building was 91 grams, I think that's 91, then what would I do? Well, I'd do the same thing. I've got all the blocks combined, divided by each block, the mass of one block, and when I do that, divide that to tell me how many blocks I have, I get 28 blocks. We're going to do the same thing. Now, what we're going to do is we're going to take same idea, but we're going to make it a chemical one. So if I had a compound, and the compound had a molar mass of 98 grams, so that's the actual compound, that is the actual molar mass. But I also knew the simplest formula had a mass of 14. So going back to what we were talking about before, I've got all of the blocks together, molecular formula, and I've got the building block, the simplest formula. So how many simplest formula units did I use to make that full compound? Guess what? Same thing. I'm going to take the total mass of everything divided by the mass of each one of those building blocks, the simplest formula units. And when I do that, I get the 98 grams divided by 14 grams per, I said 98 grams, but 98 grams per mole divided by 14 grams per mole, the mass of the block, and that would give me 7 units, 7 building blocks, 7 simplest formula pieces. Okay? Now we want to take that and we want to bring it into or build it up into something a little bit closer to what we are going to be using to find molecular formulas. But this needs to make sense. Okay, now I have a compound where I know the simplest formula is CH2O. So I've done the math before to figure out the simplest formula. Right? We did that last time. So I'm also going to be told that the molar mass of the actual chemical formula, the molar mass of the molecular formula, is 240 grams per mole. So what's the molecular formula? Right? That's getting closer to the questions that you're going to be actually needing. Well, what do I need? I need the mass of all of the things together. Got it, 240. And I need the mass of each building block. I don't have that, but I do have the building block. I do know what the building block looks like. So I know that the molar mass of the actual formula is going to be treated as all the blocks together, and the molar mass of the simplest formula, which I don't know yet, but I do know the formula, that's I'm going to treat as the molar mass of each block. So molar mass of that simplest formula, take the simplest formula, find its mass. 1 carbon, 2 hydrogens, 1 oxygen, 30 grams per mole. So now I know all the blocks together and the mass of each block. So do that. Same thing as before, same thing as the Lego, same thing as the bag of blocks. All of the blocks together, 240, divided by 1 block, because they're all the same, 30, divide that, and I get 8 blocks. Now that isn't the final answer anymore, because the question is, what is the molecular formula? But I know that I had 8 of those blocks. So if I took 8 of those blocks, what would happen? Well, I would take the block, multiply it by 8, and I would get what the molecular formula is. That is what we're going to be doing. So what's going to change now? The only thing that I'm going to change now is I'm not going to tell you right away what the simplest formula is, because we know how to find it from last time. So this becomes the kind of question that you're going to see, where you're told the percent composition by mass numbers, and you're given that one extra piece of information, the molar mass of the final thing. So you're going to go through all of the exercise to find the simplest formula, and then you'll go and do this last piece. So you'll set up a table like this to find the simplest formula. You know how to fill that in. I'm going to jump ahead because we've done that a bunch of times, and I'm pretty confident that you know how to do it. If you don't, go back and watch the simplest formula video, get some more practice. But once you've done all of that math to get the simplest formula, you're now going to move on to the next piece. So there's the question again, exactly the same. There's the simplest formula that we just figured out previously. Now I need the molar mass of it, because I need the mass of each block. The question told me the mass of all of the blocks together. So I have all the blocks together as 204. Now, I'll sometimes give you decimals, sometimes not. This one, I've given you the decimals, so 204.23, give or take, divided by the mass of each individual simplest formula building block is 68. And that gives me roughly 3 blocks. Now, it's going to be pretty close. If you did that, of course, because of the decimal, it's not going to be exactly, but it's pretty close. Then I'm going to take my simplest formula, which I figured out, multiply it by how many blocks I've got, 3, and that's going to give me my molecular formula. So not much different from what we were doing before, and it's hopefully a pretty sensible thing to do. The only thing that's different is you're not talking about a bag of blocks that you can maybe visualize. Okay, I'm going to leave you with one to try. It's this one here. You may need to pause the video while you work it out. And then, of course, there'll be some practice questions and some assignment questions and so on. Okay, at the end of this, we should be able to do a full molecular formula style question given percent compositions and the molar mass of the actual chemical formula. At no point will I really change it up other than maybe to tell you a little story about the compound or something like that, but you'll always be given percent compositions and a molar mass of the actual chemical formula. And we'll talk to you another time.